In this video, we're going to be simplifying some rational expressions, all right? And I think it's easiest to see what I mean by that by just trying one, okay? So here we have kind of a couple of polynomials over another couple of polynomials that are being multiplied together. And if I try to factor kind of the top and bottom of each part here, watch what happens. This is, of course, going to be, let's see here, x minus 5 and x plus 2. All right, on the bottom, if I factor this is going to be, I think, 7 and 5 going to that, and the 7 will be positive. So x plus 7 and x minus 5. All right, on the other side, what we'll have is, I think, 7 and 3. The 7's positive again, so we'll have x plus 7 and x minus 3. All right, and then on the bottom, multiplies to be 14, adds to be 9. We are looking at 7 and 2, and they're both going to be positive. All right, so x plus 7 and x plus 2. Okay, so basically you're factoring all of these, and then because this is being multiplied together, if we have factors on the top and the bottom of our fraction bar, they can just cancel. So check this out. Do I have any other x minus 5s? Yeah, there's one. So we're going to cancel that part. X plus 2, there's one on the bottom. You can only cancel if it's one on the top and one on the bottom. You couldn't cancel if it's both on the same. X plus 7, yep, there's one there. All right, and that leaves us with just these two, and those don't cancel. So the answer is going to be x minus 3 over x plus 7 because everything else canceled. Now, they won't all cancel like that all the time, but in this one, I wanted to show you this one first because a lot of things did cancel. Let's try a couple more. I got a couple more rational expressions that we need to simplify. And in this first one, we're just going to try to take out as much as we can. If we can factor, that's great. If not, maybe things will cancel later. All right, so it looks like on this top left side, what we can do is take out a 4, and that's going to leave me with x minus 2. Right, on the bottom, I think I have to leave this as negative 3x. Maybe that can simplify later. Same thing on the top over here. I think that has to stay 12. And then notice over here, this, if we're trying to get things to cancel, here the x comes second, whereas over here it came first. And 4 is half of 8, 6 is half of 12. So if I switch those around, check this out. Watch if I take negative 6x and then positive 12 or plus 12. In order for me to get a negative, or not negative, an x minus 2 out of that, I think I have to take out a negative 6. All right, and when I take out a negative 6, left over is going to be a positive x minus 2. And then those will cancel, all right? So let's see if we can do some canceling here. The x minus 2's will cancel. 12 over 6 is 2, and it'd be actually a negative 2. So I think I'm going to have a negative 2 on this side. You can put over 1 if you want. And on this side, it's just going to be a negative 4 thirds x. Negative 4 over, I should say, 3x probably. All right, and then on the top, I think we can get a negative 8, or a positive 8, excuse me. Negative is a positive 8. On the bottom is going to stay 3x, all right? And I think that is it with that one. So from that kind of mess up there, it came all the way down to 8 over 3x. In the second one, you'll notice a little asterisk. We'll get to that here in a second. But let's just start with this left side. I can't do anything with the 4x squared yet. Right, 4x squared is going to stay like that. However, x squared minus 16 is a difference of squares. And what I can do with this one is take out, that's going to be x plus 4 and x minus 4 because of the difference of squares. All right, and then over here, this is what's called a difference of cubes. Right, and I don't expect you to remember that, but the formula for it is down here, where if you have something cubed minus something else cubed, in our case, x is cubed, and over here, what is 64? What cubed is 64, I should say? Well, it's going to be 4, all right? And so my a is going to be like our x, and the b is going to be like our 4. All right, so if we kind of use that and fill in this with all our a's and b's, in our case, x and 4, that will give us what the difference of cubes is, all right? And something will probably cancel. So on the top here, instead of a minus b, I'm going to have x minus 4. X minus 4, and then a squared, that's going to be like my x squared. A times b, well, x times 4, we usually say the number first, so 4x plus, and then b squared is going to be 16, 4 squared. Okay, and then typically, this does not, in fact, I want to say almost always, don't quote me on that, but I want to say almost always this cannot factor anymore, right? The only thing that you can take out of that is this kind of first part, and that's why they write it in parentheses. Right, and then I do have this 2x on the bottom over here. So let's see kind of what can cancel, if anything. And it looks like maybe on top, instead of saying 4x squared, if I want that to probably cancel with the 2x, it would be the same thing as saying 2x times 2x, right? 2 times 2 is 4, x times x is x squared. And so then one of those two x's will cancel, and we're left with one of the two x's on top, right? Of course, this x minus 4 that I took out is also going to cancel. And so the only other thing on the top is then this trinomial over here, which is x squared plus 4x plus 16. Make my fraction bar a little bigger. And on the bottom, I think everything canceled except for the x plus 4, okay? Now, it'd be nice if that would simplify a little bit further so you can cancel more, but I think that is it. So you have to leave your answer like that. All right, now these were two where we multiply them together. We have two more, we're gonna do some dividing. All right, the last two problems we're gonna do today involve some division, okay? And sometimes it's kind of hard to tell when you have a fraction divided by a fraction. So I tried to make the actual division bars a little bit bigger. So this is gonna be like our numerator, if you will, over the denominator. And if you remember back to grade school, when you have a fraction over a fraction, you're going to flip and multiply, all right? Keep, change, flip. There's all sorts of different ways that you can remember that. Anyway, what we're gonna do is we're gonna take this one right out just like it looks, 6x over x squared minus 4, and then times, I'm gonna flip the other one. So my bottom is gonna be on the top and be 2x plus 4, and then this is gonna be on the bottom, 3x minus 9. Okay, then what we're going to try to do is just factor out anything that we can. 6x probably has to stay how it is, 6x. And then over here is the difference of squares, so we can say x plus 2, x minus 2, times, over here we can take out a 2, leaving us with x plus 2. That'll cancel later. And down here I think we can take out a 3. So that's going to be x minus 3. All right, let's see, does anything cancel right now? Well, the 6 and the 3 are both divisible by 3, so we can take out a 3. And 6 divided by 3 is 2. 3 divided by 3 is 1, all right? What else can we do? The x plus 2 and x plus 2. And then I don't think anything else can simplify. So I'm just going to rewrite this up top here. So we have on top 2 times x times 2, which is going to be 4x. All right, 2 times 2 is 4, and then x. And then on the bottom, the 1 times anything is going to be itself, so we really don't need the 1. But I'm going to have an x minus 2 and an x minus 3. X minus 2 times x minus 3. And was that it? Yeah, so I think our answer is this. Nothing else can factor out of that. So that's as simplified as that rational expression is going to get. Okay, this next one's kind of cool. It all ends in 12s, and so we can maybe do some factoring as we simplify this. Let's find all the factors of each here, okay? And so like this top one is going to be x and x, and it looks like since this is a positive and so is a 12, it's going to be a plus 3 and plus 4. Plus 3 plus 4. In fact, I think most of these are going to be 3s and 4s of some variety. This one, since it's a negative 7 and a positive 12, is going to be x minus 3 and x minus 4. All right, again, I have my big fraction bar there. These things are kind of like equal to each other, although I don't really like to use equal signs when we're talking about expressions. The next one down, since this is a positive 1, you might say right there, this is going to be a positive 4 and a negative 3. So x plus 4, x minus 3. And then the last one is going to be the exact opposite. It's going to be x minus 4, x plus 3, x minus 4, and x plus 3. However, we do have to do the keep, change, flip thing, or flip the bottom, however you learn that. So I'm going to rewrite this for us, so then we can start to cancel those out. All right, so what I did there is I went ahead and I kept the top part the same, all right, and then this bottom one, I flipped those. So like you can see, this on the bottom was x minus 4, x plus 3, and now it's on top, x minus 4, x plus 3. So then, once that's flipped and this is being multiplied, no longer divided, then you can start to cancel things if it's on the numerator and the denominator for both. Okay, so for example, let's see, do I have any other x plus 3s on the bottom? No, I actually don't. All right, so that's going to stay. X plus 4, however, there's one there and one here, so that's going to cancel. X minus 4, same thing. There's one there and one here. And then another x plus 3. I have one on the top, but I can't cancel there. It has to be one on the top, one on the bottom. And so I have, if you look at what I have left, I have 2 x plus 3s on the top and 2 x minus 3s on the bottom. So the way to actually write this answer is x plus 3 squared over x minus 3 squared. So So kind of a cool one to end on. But anyway, that's how you simplify rational expressions.